Thank you for considering my grant idea for Cricket in the Classroom. This video is hopefully going to give you an idea of how I've used technology and other resources over the past few weeks to get students ready for an engineering design challenge in which they work to build a seismic safe building. So the content area that we're working with is earth science, and students in Ohio need to know like how seismic energy is created, how it travels through the earth, and a little bit about like how buildings and people can be safe in these circumstances. So we have been working with curriculum dealing with convection currents and looking at how plates move and how this tectonic plate movement creates waves of energy. And so we've got a couple of different showcase of ideas of what we've been working with. So the video will be broken up into where we've been, so you can see how we've used technology and created some great work to show understanding, what we're currently working on, and where we're going, so that you can see the final product. Students have been able to share their understanding through Flipgrid video responses, by building claymation videos, creating sketch notes on their iPad in the Sketches Pro app, even using the Keynote app to create short animations to show concepts. After learning a little bit about earthquake safety by watching some public service announcements and by talking through our own fire and tornado drill safety, students were asked to go ahead and create a public service announcement for earthquake safety that could be shared with other people. The prompt is for a 30 to 60 second video, and students were required to think about earthquake safety before an earthquake, during an earthquake, or after an earthquake. The prompt is to use either the Clips app or to use Lego like stop motion, or to use the Toontastic app. So where in your design do you have your structure?
We have our structure right here.
Okay, so the table is going to be where your first, do you have more than one Lego person in your scene or just one?
Just one.
Okay. How are you going to show her covering her neck and her head? Okay, so you've got 3 really good ideas so far. Being careful around broken glass and debris. What's your 4th one that you're going to put down?
Stay away from damaged areas.
Okay, so where would they go instead of being around the damaged buildings?
Stay in a place like that in the commercial buildings.
Corner without windows or like glass.
Okay, and then you'll show. Okay, so you'll show this in your. Are you going to do the Lego, the Clips, or the Toontastic? Okay, so picking a scene where you can have them like so that your little person is in the corner and not by windows. Good idea. Nice job. After students review this project and look at how people can be safe before, during, and after earthquakes, they will be challenged to design, build, and test a seismic safe building. This will require them to mix a bunch of different tools from cardboard to 3D printing, recycled products, and some tech tools like using a digital journal in the Pages app. Students will have the opportunity to do some research on building strategies, and then as they build, they'll be allowed to test their design using a Sphero robot. The first test that they do will allow them to take Sphero, put him inside of a shoebox, and attach their design to the shoebox. Sphero will be set up for raw motor and will shake the box, so they'll be able to see just how well they were able to use seismic safe building to protect their building from him in the box. When it's time to put their building on the big shake table for their final test, Sphero will be used to sense the lateral and vertical movement to make sure that everybody is on track with having the same level of earthquake. So here are a few pictures and videos of this project in the past. This shows the template that students will be working with in the Pages app. They will have to do some research, they'll have to design their building. This requires them to have a budget and select materials that will fit within that budget. They also have to use this engineering journal to record what area their building would be built for, and to track their finances, and then finally share their design. This is what the purchasing area looks like for students when they are going to select materials to put into their building. And here are some student work samples showing what they've done in the past using simple materials. Students are able to use the Sphero robot inside of the shoebox, and the movement of the Sphero actually shakes the box enough so they can test their structure. When it's time to actually test on the big shake table, Sphero goes inside of their building and will light up with different colors depending on the amount of movement laterally and vertically applied. So this is where we've been, where we are right now, and where we are heading. Instead of having one 7-minute clip of one lesson, I thought it would be helpful to show you how I integrate technology from start to finish with everything from stop motion to sketchnoting, building videos, and in the end we have an engineering challenge that allows students to show what they know.